Hello, everyone. Welcome to Theo-MathProblemSolver. In this particular episode, we are going to look at the method of characteristics. Are there some, approaches that we can leverage to solve PDEs? But this content is all about that. And at this point, if you have not subscribed, please do so. Turn on the notification button so anytime I release new content to be the first to receive that. All right, let's get started. Now, suppose that suppose U is a solution to the PD, and the PD we are talking about, as we mentioned the last time, the PD we're looking at was this, the general form of the PD that we're looking at. Okay. So depending on how many n's you may want to have, if n, for example, we said that this, when we expand it, we can have it as what? But when j is 1, we're going to have something. Let me ignore the components. So like I'm going to have a1, the partial of u with respect to 1, plus a2, the partial of u with respect to 2, plus a3, the partial of u with respect to 3, up to the case when j is n. So in that case, we're going to have an, the partial of u with respect to n, equal to c, okay? So this is just an expanded, this is just an expanded form of this compact, first order linear PDE, okay? This is an expanded form of that, okay? Depending on how many, independent variables you have, you can always sort of write it in this form, okay? Good. So let's take note. This is something we are going to, use to tackle most problems, okay? And I promise you're going to encounter of this nature. So it is important that we understand the main problem, okay, before we can, touch on other things. So let's take note of that. Now we want to say that U is a solution of this particular, PD, okay? And let U, A, J, and C be differential, continuously differentiable. And we want to also say that, and let Xi1 up to Xi end V also be the solution of the given ODE. So this is our ODE we are considering. So this is the ODE we are considering. Oh, is that okay? And so when you look at, now I want us to link something here. Let's try and link something. Remember that AJ is AJ, we have AJ to be composed of X and U of X, right? AJ has coordinate X and U of X, right? So over here we have AJ to be that, so we have AJ. Remember that Xi1 and Xi up to Xi1 up to Xi end are just solutions of these ODEs, right? And V is also a solution of the ODE, given ODE. Is that okay? Very good. So over here, what happened is that all the ODEs, or the terms that correspond to the Xi's are always the coefficients of, or the coefficients AJs. Okay, so let's take note of that. Please, do we all get it? So always the ODE, okay, or the term that correspond to the terms that correspond to the ODE2. Let me be more specific over here so that everybody will understand it. All right, so we are saying that the AJs will always be equal to the differential of the xi's with respect to the j's. Is that okay? That's a simple put. So the aj's will always be equal to the differential of xi j's. Okay, is going to be the differential of the xi j's. Okay, so let's take note, and that there's v, the differential of v will always correspond to the right-hand side of the given ODE, of the given PD. So let's take note of that. Or what I was trying to say is that the derivative of the xi's with respect to the j's will always correspond to the aj's, and that the derivative of the derivative of v will always correspond to the c's. Okay, that's all I was trying to say. The derivative of the xi j's, okay, will always correspond to the aj's, and the derivative of the v will correspond to the c. Is that okay? That is all I was trying to say. Good, good. So let's take note of that. And over here, I want to point out that this is what we call this particular ODE. We said it is called the characteristic system. Okay, we call it the characteristic system. We call this one the character system. And then I also want to point out that the xi's and the v's are what we call the characteristic. Okay, we call this to characteristic. Okay, so let's take note of that. If you have, at this point, if you have any questions, please put it in the comment section and I'll address that. Very important, because the reason I'm spending time to really explain this is because we are going to use this to solve a lot of problems. Okay, so for you to really understand this, the best is that we're going to look at so one or two things, then we solve problems so that you really, appreciate all of that. Is that okay? So let's take note. Let's take note of this. Very, very important. Let's take note. All right. So let's look at the first problem of the day. So how do we solve such a problem? How do you find a general solution U of two variables X and Y to this particular PDE? How do we do that? So as I mentioned that the xi's correspond to the X and Y, okay? So I want to point out over here that the xi's, okay, xi always, so before we kind of look into the solution, I want us to sort of take note of this, that V of t, is equivalent, is the same as U of xi of t. Let's take note of this. Always the solution, so the solution to this ODE can be obtained from this. Please, the solution of the solution of this particular ODE can be, related in this way. So I want us to kind of take note, and that the xi j's, the xi j's correspond to the x coordinates. Okay, correspond to the variables, the independent variables. They correspond to the independent variables. So let me take note. Let's take note of that. Correspond to the independent variables. Please, let's take note. And then the v correspond to the u solution. Okay. Please, let's take note of that. The v correspond to the u solution, and then the xi j's correspond to the independent variables. So please, I want us to please take note so that once I begin to talk about them, you will really understand them. All right. So on that note, let's kind of jump into the whole thing. So I want us to kind of use the same language as before. As before, we were not using X and Y. So I want us to use 1 and 2. Is that okay? If it may make sense. So I would say that So in the same language as before, I'm going to have, so in the same language as before, I'm going to have, so this, let me be, this PDE, which is y multiplying the partial of u with respect to x plus x partial of u with respect to y equal to 0. I want, remember in our case, in this particular system, when I was explaining, we're kind of using 1, 2, and all of. So I want us to maintain the same thing. I want us to be very, consistent in that. So I don't want us to use x, y, and all of that. Okay. Okay. So I want to change that to a different thing. So let's change it. So by changing it, we're going to have, so my y with respect to, my y will correspond to x2. And that is that okay? So I'm going to have x2, the partial, instead of, remember that I said that this is the same as, if I give it, it's the same as the partial of u with respect to x, right? We did something like this. Oh, and this is also the same as the partial of u1. Is that okay? We said that these are the same. So please, let's take note of that. These are the same. They are all the same. So it's just a language. It's just a language. Okay, we have to just learn the language. So x2, the partial of u with respect to 1, and 1 we said correspond to your x. Okay, very good. Good. And this becomes what? Your x now becomes your x1. And then the partial of u with respect to y becomes the partial of u2 equal to 0. Is that okay? So over here, I kind of stated that, or I have that. My x now becomes my x1, x2. Is that okay? The x that we used over here, the x that we're using over here, okay? So the x that we're using in this particular PDE, that's what I'm denoting over here, okay? So now it's as if we have only, our n is 2. So in that case, we are dealing with only 2 independent variables. Is that okay? Okay, so we are only trying to maintain the language so that you don't get confused. And recall that, let's do a quick recall. So recall that if n is 2, in that note, if n is 2, we are going to have what? If n is 2, we're going to have what? A1 per, according to the general form. Record it. We are trying to record the general form, okay? So record the general form. So record the general form of a first order PDE. We said is what? Remember now we only have two. Remember that now we have only two independent variables, x1 and x2. Okay. So on that we're going to have what? A1 x plus what? Okay, multiplying the partial, right? So the partial of 1 with respect to u plus what? A2 and the partial of u with respect to 2 equal to what? C. Is that okay? Very important. So let's take note. That is all we are going to have. Is that okay? Now, remember that we need to extract our characteristic system. And this is what we kind of considered. So this is what we said is our characteristic system. Is that okay? This is our characteristic system. We said that this is our characteristic system. Is that okay? And we said that per our characteristic system, we said that our the differential of xij's, okay, correspond to your independent variables, and then the v correspond to what? To the u's. Is that okay? To the c, sorry. The v correspond to the c. So let's take note of that. So this means that The character system will be what? The characteristic system will become what? So what to be xi of xi? What to be the differential of xi1? Xi with respect to x1. So the differential, let me take my time, write it well. Then the differential of xi of, oh, let me write it well. So the differential of xi with respect to x1, which is 1, will be equal to what? Will be equal to the a1 or correspond to the a1 here, okay? So it's always as per the system, we said it's always equal to your a1. Okay? And then the derivative of xi with respect to x2 will be what? Will be your a2, okay? And what will be the derivative of v? The derivative of v, we said it is always equal to what? Your c. Is that okay? We said it's always equal to your c. Please, are we all getting it? Good. Now, if that's the case, then by using this, we can see that our A2 per the given PDE, this given PDE, we see that our A1 is X2 and our A2 is what is X1. Is that okay? But remember that I also said that I also pointed out that your Xi1, Xi2, I said that. So I said that your Xij's correspond to the independent variables, right? Independent variables. I said that your Xij's correspond to the independent variables. On that note, my Xi1 will be what? Your X1, and your Xi2 will be your X2. Let's take note of that. It's very important that we understand this basis. Okay? It's important that we understand this basis. All right. So let's move on. Let's move on. Now, what it means is that now it just means that my characteristic system will now be what? The ODE will now be what? Your differential of the Xi1 with respect to x1 will now be equal to what? What is my x1? My x1 is what? Per the given ODE, per this given ODE. Remember that your ODE is this. Your ODE was given as what? Your PDE was given as S2 x2 the partial of u with respect to x1 plus x1 the partial of u with respect to x2 equal to what? Equal to 0, right? Very important. Now, since we said that your a1 correspond to x2, same, and your x2 in this case will be what? Your x will be what? Xi2, right? Your x2 will be Xi2, and your x1 will be what? Xi1. Is that okay? So we're going to have my A1 here, over here, my A1 here. My A1 here is what? Is X2. It's X2. But my X2 is the same as what? Xi2, okay? So I'm going to have Xi2. Is that okay? And then my derivative of Xi with respect to X2 will be what? Will be what? Xi1. Good. So let's take note of that. Please, is that okay? So let's take note. What about my V? My V will be what? So when we look at the C in the given PD is what? 0. Is that okay? Very good. Now what we are left to is to solve. What we are left to do is just to solve them. Is that okay? Now we just have to. So when we look at, let me bring this one here. My V prime is 0. Okay. But then when we look at these two, they're easy to solve, right? You can write them in matrix form, then we can just solve them. So we see that this one, we can write them in matrix form, then we can solve them directly. So we have your x1, xi1, xi2 prime to be the same as what? 0, 1, 1, and what? 0. Is that okay? So what we can do is that we can find the vectors of this, the eigenvalues of this, so suppose if this is your matrix, let's consider your matrix A, we can find the eigenvalues and it correspond eigenvectors, then we form the general solution for this system, okay? And that's the easiest way to solve this. All right. So what that we need to do to find the eigenvalues of this, and we kind of go straight to the point, okay? And to find the eigenvalues of this, so first we need to find the eigenvalues of A. Okay. So to find the eigenvalues of A, we can just use this lambda squared minus what? The trace of A lambda plus what? The determinant of A equal to 0. Is that okay? So this is a 2-byte. What is it? The trace is 0 and the determinant is what? The determinant will be negative, and that gives us what? So we see that the trace is 0. So the trace is 0. Then we have the determinant. What will be the determinant of this? So that will be minus over here, -1 equal to 0. So on that note, your lambda will be equal to what? Plus or minus 1. Is that okay? Now we need to find the corresponding eigenvectors for these eigenvalues. Is that okay? So we need to find the corresponding. So to find the corresponding eigenvectors we use. So to find the corresponding eigenvectors, we have to. So to find the corresponding eigenvectors, we kind of use this. Okay. Suppose that U is some vector, let's say U1 and then U2. Is that okay? So on that note, we're going to have, what is your, so for, let's say for lambda equal to 1, what's your matrix? Your matrix is 0, 1, 1, 0, okay? And your vector is what? Our vector, we consider U1 and U2. So we have U1, U2 equal to the lambda. Lambda, we are considering the lambda, the first lambda, which is 1, multiplying your vector, which is U1, and then U2. Now, we just have to solve for only one system, and that is so. So by solving that, we're going to have what? U2 equal to what? U1. Is that okay? So we're going to have U2 equal to U1. So on that note, so it means that our first U1 will just be what? Our first U will just be what? When U1 is 1, our U2 will be what? 1. Is that okay? I hope we are all following. All right. Now we also have to look at the other eigenvalue. So for lambda equal -1, we use the same thing, the same matrix, which is 0, 1, 1, 0, all multiplying the vector u1, u2 equal to negative multiplying u1 and u2. Is that okay? And when we solve, you should have u2 to be equal to minus what? u1. So on that note, your u will be equal to what? 1 and -1. Now we need to find a general solution for this. So the general solution for, so over here, we kind of see that it is easy for us to sort of, point out that the fundamental solutions, we already know that the fundamental solutions will just be what? We already know that the fundamental solution, let me write it well. So already we know that the fundamental solution will be what? E to the power t and then e to the power minus t. This would be our fundamental solution. Then what then becomes the general solution? But remember that we also have our our v, the derivative of v with respect to the given independent variable. We had 0, the derivative, which means that even when we solve this, that its solution, the solution v with respect to time will just be equal to some constant, right? Let's call it some constant 0. Okay, to some constant, let's call it v naught. Okay, so which means that, let me just extend this a bit. Which means that the general solution to the characteristic system, so the general solution will be what? Especially when we try to, combine your xi. Let's look at the xi1s and the xi2. Okay, so first let's look at the xi1 and xi2. So the easiest solution to that, the xi1 and xi2, let's look at that one. The general solution for the xi's, j, okay, will be, let's call it c1, then our vector multiplying e to the power t plus c2 u to our corresponding vector, okay, multiplying e to the power minus t. Is that okay? Now, so you have our c1. What is our u1? Our u1 was what? 1, 1, multiplying e to the power t plus our c2 was what? 1 minus 1, multiplying that. Now, when you expand, you should get, when you expand, then you correspond, looking at it corresponding j. So remember, you have two j's. You have j1, j2, right? You have j to be equal to 1 and 2. So we will say that the first general solution for the xi1 will be equal to what? c1 multiplying e to the power t plus c2 multiplying e to the power t. And then xi2 will be equal to c1 multiplying e to the power that minus c2 multiplying that. So we have something like that. But already we know our v of t to be equal to what? V naught, right? Our v solution was this. At this point, what's the next thing to do based on that? What's the next thing to do? What do we do next? So at this point, what do we do? Remember, we want to find a general, but this is not, remember that we said that the solution to this particular let's go back to refer to the given. We said that we always have to, you know, look for u, right? The solution we are solving is u. So we have to always convert it back to u. So how do we do that? How do we get that? Okay. That is what we are looking at, right? How do we do that? Remember that now I want us to notice something here, that if we should pick u1 xi1, I want us to notice something here. If you should pick xi1, let me write it well. Notice something, that if you pick xi1 and then square it. So let's pick xi1, then we square that. So let's pick xi1. I want us to look at something here. Then we square xi1. Then we pick xi2. Okay, we also squared xi2. Let's pick that and square that. Then at the end of the day, let's try and find the difference, okay? I want you to do that and let's see what we are going to get. Let's find the difference. So the difference will be what? When you find the difference, so we square that, then we find the difference. Because over here, when we expand this, we are going to get also square the first. We're going to have C1 squared multiplying to that, then twice their product. We're going to get to 2C1 C2 e to the so we have that so that will be 0, and then square the last. We're going to have C2 squared e to the power minus 2t. Then this we're going to have C1 squared e to the power 2t twice the product. That becomes 2C1 C2. Then we square the last. That becomes C2 C2 squared e to the power minus 2t. Okay. Now, if you subtract them, we are going to have what? We only have so that will add up. That gives us what? 4C1 and the C2, right? This is equal to some constant. Let's say C, right? So it just means that when we find their difference, it's just going to be constant, right? So if their difference is still going to be constant, which is independent of t, then this can also be seen directly from the differential equations. Okay, it's obvious there. So the characteristic curves are particular, hyperbolas. Okay, and the solutions remain constant along these, hyperbolas. And this also, tells us that let me be more specific. So this also tells us that our u of the xi j's, or let me say xi1 of t, xi2 of t will just be equal to v naught. Remember, v naught is some constant, okay, which also does not depend on t. No, so this may kind of give us the idea to look for the solutions u that are only of x1 squared minus x2 squared. Okay, is that okay? You remember your xi1 is the same as your x1, and your xi2 is the same as your x2. Is that okay? Very good. So, so we may want to, find something of this nature, because their difference gave us some constant. Their difference just gave us some constant. So we may want to find a solution x1, x2 of the form x1 squared minus what? X2 squared. Is that okay? So we may want to find a solution of this. But can this really be a solution to the given PDE? We can try and see if this indeed is a solution. If this is a solution to the PDE, then so be it. So it means that we've been able to solve the problem. Is that okay? Is that okay? Remember, because this was a constant. Remember this. Remember when we look at the difference was a constant. It just tells us that the characteristic curves are just hyperbolas, and some solution remain constant along these hyperbolas. Okay. Okay. Let me So let's try this. Whether this solution will satisfy the given PDE. Remember the PDE, our PDE was what? Oh, let's go back. Our PDE, our given PDE was let's see, was this. Okay, so that is YUX. Okay. So the PDE that we're given was YUX plus XUY equal to 0. Let's see whether this particular solution would satisfy this. Okay, so the first thing to do now, remember that your y is the same as your x2, okay, and your x is your x1, okay. So you have your y is what? Your y is your x2, and then we have to find the partial of u with respect to x, and that gives us what? So over to do this, we use the chain rule. So we cover the input, which is x1 squared minus 1 x2 squared. We cover that and differentiate f, and that gives us what? F prime. Okay, then what happened is that we are going to differentiate, we cover the f and differentiate the input, which is with respect to x, which gives us what? Which gives us what? 2x1, which gives us 2x1, okay? Then plus, so we are here, plus your x1, so I have x1. Then I find the partial of u with respect to y. Your y is your x2. So when we do that, we're going to have what? So we're going to have minus, so we are going to have minus 2x2 of f prime. Is that okay? And what does this give us? This should give us what? 0, which is a constant, right? So this has already satisfied it. So this means that indeed this is a solution, or this is a solution to the given PDE. At this point, if you have not subscribed, please do so. And also, if you have not turned on your notification button, please do so. So anytime I release new content, you'll be the first to have that. All right. So stay blessed, and let's also look at the next question. And at this point, let me also say, if you have not shared the content and you have not done well, please do so. Share your content to your colleagues, to your loved ones. So let's help demystify the myth around mathematics. Hello, everyone. All right, so let's kind of look at Cauchy problems, because the problems we have solved so far does not relate to initial conditions. Okay, we were just looking at the general solution of the given PDE, but we may at this point want to look at its particular solution. Okay. So with a particular solution, we are kind of looking at a situation where a given PD is supplemented with with the initial condition. Okay, with the initial condition as this. Okay, all right. So with the same PD first order PD, of which we have that, we want to supplement that with a given initial condition. Initial condition. Okay. So that is the point, or that's the whole thing we are trying to look at, because most problems we will be confronted with in life, okay, being it in the banking industry, being it in the semiconductor industry, being it in the engineer, or wherever you want to apply PDs, there will always be initial conditions. So we may want to take note of that. All right. So let's look at what are some of the things we have to take note in order to address those problems. Now, um, so suppose we have these, characteristic system, and we remember we kind of we've already laid the foundation for all of these ODs. Now, this is the initial condition that we have introduced. So we want to say that xi of z of z, this time around that when time is 0, we're going to have g equal to g g of z, okay? And that when time is 0 at the v, at the solution v, we're going to have u naught of z of u naught of g of z, okay? You're going to have that. You know, this as we have, as I've also pointed out, that the xi j's relates to the independent variables. Let me remind in the independent variables, okay? So that I always want to draw attention to, so that when I'm referring to that, you would know that the xi just just relate to the independent variables. And then I also mentioned that the v's relate to what? The solutions u. So please take note of that. That the xi j's correspond to the independent variables, and then the v relate to the u. Okay. Okay, so please let's take note of that. So I'll pick an example so that we can look at that and relate it to this and how best we can move from there. Is that okay? Very important. So let's look at the first example. All right. So this is our first example. How do we approach this particular problem? And that's what we are trying to do. So solution. So given this Cauchy problem, which is u partial of u with respect to the first independent variable, okay, which is said is x1, and then the partial of u with respect to the second independent variable, which is x2, equal to 2. And then we're given this initial condition, okay, equal to 0. On the line x1 equal to x2. Is that okay? Now over here, we know that this is so with this, we want to point out that your A1, so my A1 in this question will be what? Will be what? Will be U. But we said that U is the same as U correspond to what? V, right? And what to be my A2? My A2 is what? Is 1. And what to be my C? My C is what? Is 2, right? Per this, when we kind of relate it to the general solution, I can just write a general solution of a PDE, of a first order PDE. We said the general solution is this nature, which is A1, A2 equal to C, right? So if that is the case, it just means that my A1 will be what? My A1, so this will be my A1, and then this will be my that, okay? So let's take note of that. Very important. Let's take note. Let's take note of that. Now, what to be so right now what we need to form our characteristic system, okay? So the characteristic system, so the characteristic system, would there be what? Let me just take my time to write it well. Xi1 with respect to time will be equal to what? Will be equal to your A1, right? And your A1 in this question is what? Is U, right? But what is U? U, we said U correspond to what? U course, it is U. Your A1 is to U, but U, we said it correspond to what? U, we said it corresponds to V. So we have that to be V. Is that okay? And that what is your partial of, what is your partial of Xi2 with respect to T? So over here, we are saying partial of xi. Remember, because xi over here, we saw that it is made up of two variables, which is z and t, and that is why we are using the partial, okay? Because this is composed of two variables, which is z and t, okay? All right. So what is our A2? Our A2 was what? In this one, we see that the A2 is 1. Is that okay? Your A2 will be 1. What will be your partial of v with respect to t? And that was what? And that is what? 2, right? So now what that we need to do is to find it, is to solve for the x's and then the v. Okay, we just have to find for the solve for the x's and then the v. Is that okay? But then remember that this in this particular problem, we're given initial condition, right? So we have to parameterize. We have to parameterize the initial. This is your initial condition, so we have to parameterize that. So by parameterizing, so we need to parameterize the initial condition. So the line. So I will say that I will state that the line. Remember that we're given a line. The line was this. X1 should be equal to this. So we have to parameterize this line. It's parameterized by, let me take my time to write it. Okay, so it's parameterized by, so what we do is that we just have to parameterize it in terms of z, right? So we parameterize that by j of z equal to z and z. The z's also correspond to your independent variables. So let's take note. And because they are the same, because this line is x1 equal to x2. So if your x1 is z, it means that if your z2, sorry, I'm sorry. If your x1 is z, then it just means that your x2 will also be z. Is that okay? So we parameterize that in terms of z. Okay? Okay. Some variable, let's call some fixed variable, let's call z. Is that okay? And this parameterization is very important for us to carry out what we are trying to do. Okay. So on that note, by parameterizing, it just means that the initial condition for this characteristic system would there be, so it just means that your xi1 would have its initial condition to be equal to the 2. So the xi1 will correspond to the first component of gz, and that is what? And that is z. And then the xi2, when t is 0, that initial condition would also correspond to the second component of g, and that is what? That is also z. Is that okay? And what would be our v, the initial condition for v at t is equal to 0? Would that one we per the theorem over here, per the theorem or per the definition over here, we call that, we said that the v will have it in when t is 0, will have its initial condition at the given or the main initial condition that the parameter gave us, right? And this was the initial condition, which was u of x1, x to be 0, right? And we said that your x1 and x2 correspond to z, okay? And so on that note, we're going to have that to be what? To be 0, because that was what we're given. We said that it is equal to 0, okay? Very good. So let's take note of that. Now we have the characteristic system, then it corresponds to initial conditions. So we can just go straight to the point and solve for the systems, right? Okay, good. Now over here, we can kind of see straight away that for over here, we see that, so over here, we see that your xi2, the solution of xi2 will be what? So your xi2 will just be what? So your xi2 of zt will be what? Who can give me the answer? Your xi2 will be what? Will be t plus some constant what? Z. Remember, Z is fixed, so the constant that will come, even though we're going to have plus a constant, but because xi is made up of two variables, so if you integrate that with one variable, the constant that we have to have that in mind, it will be the other one, which was fixed. Is that okay? And that's why we have t. Okay, let me just, how do we get that? But let me just do some illustration. Remember, we have, let me just do some illustration here. We have the partial of xi2 with respect to t equal to 1, okay? And this can also be written as, what? Okay? Now, when you take the integral on both sides, so when you take the integral on both sides with respect to the partial of the, when you take the integral on both sides, you should have xi2 to be equal to the integral of what? Partial t. And that when you integrate this, when you integrate partial t, we're going to have what? T plus some constant. But remember that your xi2 is made up of two variables. Xi2 is always what? It's made up of xi1, or is made up of the independent variables z and t. Okay. So because we've integrated with respect to t, that it just means that we're integrating with respect to t, we're fixing z. Okay. So the constant that we need to add will be what? Will be our z. Is that okay? As a constant. It's not using any other constant. We just have to use z as a constant. Is that okay? So that's how come we had this. Okay, good. And what about this? So what becomes our v? The solution v, what to be the solution for v over here? So v will be what? We know that the partial v with respect to t is just 2. But what to be the solution to that? So the same thing, we just have to also use. So this is the same. We can also write this as what? As the partial of t with respect to t to be equal to 2. Okay, to be equal to 2. Okay, so by integrating both sides, by integrating that, we're going to have what? So this is almost like you having something as this. Okay, now when you integrate the v, you get what? V. When you integrate 2, you get what? 2t plus some constant. And that will be what? That constant should, that, remember, as we're integrating v with respect to t, we're fixing the z. So in that case, the constant that should come to mind should be z. Is that okay? Good. So now we have our xi2 and then your v. So now what then becomes our what then becomes what then becomes our the partial of xi1 with respect to t. Remember the partial of xi1 from here, the partial of xi1, let me pick a different pencil. So we have the partial of xi1 with respect to t to be equal to v, right? But what is v? Or do we know the solution v to be what? We know we already have v to be what? 2t plus z, right? So if you are integrating this with respect to t, we are going to have your xi1 to be what? So we're just taking the integral for 2t plus xi that. And that should give us what? T squared plus what? Zt. Zt plus what? Plus z, right? But remember, each of that, we need to kind of remember, we have initial conditions. We need to use these initial conditions. So far, we've not used the initial conditions. So we have to use the initial conditions to solve that, right? So by using the initial conditions, so when we evaluate this at the initial conditions, when t is 0, from here, when t is 0, we're going to have what? When t is, we're going to have z to be equal to what? We're going to have z to be equal to what? We're going to have z, right? Please, are we okay? If you have any question, please kind of put it in the comment section, and I would attend to you. But then if I were you, I would just probably pause the video and try to see what I'll be able to find my Z1 and Z2 and V. All right, so what did we get? But before we jump into that, let me clarify something here that when we find a particular solution for this, remember T was when T is 0 here, per the initial condition T, that will be Z will be equal to what? Will be 0. So on that note, we're going to have our V, so this plus our V to be equal to just 2T. So we just have to sub this into this, and by subbing on that note, we're going to have only V to be this and not that. So let's take note of that. So on that note, we're going to have this to be the integral of what? 2T, the partial of T. Okay, good. So that gives us what? T squared plus what? Some constant what? Some constant Z. Very good. So let's take note of that. All right. So let's take note of that. So that means that we have our Xi1 and then the Xi2. What's our Xi2? Have you already solved our Xi2? Yeah, already Xi2, we kind of, let me see where. I think Xi2, we've already done that here, of which we had it over here. So now we've been able to be able to find our Xi1, Xi2, and then our V. Is that okay? Now, all that we need to do is to kind of, sort out one or two things. But remember that our Xi1, now remember we have our Xi1 to be this. We now have our Xi1. Now we know that our Xi1 is what? Let me be more specific. Our Xi of Zt to be equal to what? Let me write it. Well, so we have Xi of Zt to be equal to T squared plus Z. So our Xi, so on that note, remember that your Xi1 correspond to your X1, and then your Xi2 correspond to X2. So on that note, we're going to have our X1, to be what? To be T squared plus Z, if that's the case, if that's what. And then our Xi2, so sorry. So our Xi2 of Zt should be equal to what? Already we know our Xi2, right? Our Xi2, we had what? T plus Z. Our Xi2, we had T plus Z. Our Xi2, we had T plus Z. So we had T plus Z. But what is our Xi2? Our Xi2 would correspond to your X2. Your X2 will be equal to T plus Z as well. Okay, very good. So if that's the case, it just you see, when we kind of when we try, we see we have Z is common to these two. Okay, Z is common to this, so we can decide to kind of make Z the subject and we equate them. So if we try to make Z the subject in this equation and this, then we equate them, we should have something as what? And we equate them, we should have something as what? As our T squared minus what? Minus T plus what? Your X2 minus X1 equal to 0. So this is a quadratic equation, right? This is a quadratic equation. And with a quadratic equation, we have that a x squared per the quadratic equation, if you have something as this, for the quadratic equation, if you have a lambda squared plus b plus lambda plus c equal to 0, then we have that lambda equal to what? Plus or minus b minus, oh, sorry. So we have minus b plus or minus root of what? B squared minus 4ac all over 2a, right? This is a quadratic equation. So we're going to leverage this tool to solve problems, okay? Good. So on that note, from this, you're going to have t equal to you're going to have what? But this can also be written as, maybe just let me just make it more simple. So this can also be written as simple as this. Okay, so let's do that. Okay, all right. So what is our b in this question is what? It's -1. So from here, our b is -1 here, and that gives us what? Positive. So plus 1 plus or minus root of. So I'll rather use this one rather. Okay, so we'll have your a is 1, so I'll rather pull that out, and then our b was -1, so -1 that becomes plus or minus root of our b is 1. Our b was what? Was 1. So -1 squared minus 4. What is our a? Our a is 1, and our c is what? S2 minus x1. Is that okay? Now let's try and simplify it a bit and see something, what we can get. So we have 1 minus 4 multiplying x2 minus x1. Is that okay? Good. So now we have this. So it means that over here we can have two solutions, right? It's kind of obvious that we can have two solutions here. And so the first solution, or the first so we can have two solutions from here, right? Can we see that? So remember that we kind of pointed out that let me use a different pencil. We kind of pointed out that u of x, now your x are x1 and x2, u of x is related to v in this way. Okay, u of x is related to v in this form. Okay, so if that's the case, remember that we can confidently write this as our solution. You can confidently have this as our solution. So on that note, our u will be equal to what? Will be equal to half of what? 1 plus or minus root of 1 minus 4 multiplying x2 minus x1. Is that okay? So we have this. Very important. Let's take note of that. Now, we can kind of, look at something really important here. We can really sort out one or two things over here, which I believe is important. You can see that when x1 and x2 are the same, something really happens. When x1 and x2 are the same, something really happens. So when x1, but this one I can write it as, so we see that when x1 and x2 are the same, so you see that if, let me use a different pencil for us to make the analysis. We see that if x1 and x2 are the same from here, we see that when x1 and x2 are the same, you will find out that your u of x will be equal to what? Half of plus or minus, half multiplying the whole term plus or minus root of what? 1, right? And if now it just we have two solutions, right? When you're if you're considering the plus side, you're gonna have half of what? 1 plus 1, and that gives us what? 1. But when you're considering the other side, the other solution, you're going to have 1 minus 1, which you're going to have. So one of the solutions is going to be 0, another solution is going to be 1. Do we get that? So we're going to have two solutions where one of the solution will be 0 and the other one will be that. Is that okay? Very, very, very important. So I also want to sort of point out that I also want to kind of point out that U may be defined, or U is defined for the situation where x1 minus x1 less or equal to. So we can say that the U would have a solution. You can say that this U will have a solution if the radicand or the term under the square root is kind of let me do something so that we can really understand what I'm trying to do. So this what's this particular term, which is under the square root, would enable us to have a solution if and only if this condition holds. If and only if x2 minus x1 is strictly less or equal to quarter. Okay, if you can only have a solution if the expression under the or the term under the square root is strictly less or equal to quarter. Okay, this is very, very important. So this is how far, I mean, we can extend the analysis of this particular PDE with it associated initial condition. And at this point, if you have not subscribed, please do so. Put your subscribe, turn on your notification buttons. So anytime I release new content, you'll be the first to have that. And then also let's help demystify the myth around mathematics by sharing this, quality content with your colleagues, with your loved ones, and so that we can at least create a community where most of us will not be afraid of mathematics. As I told you, mathematics can be mastered. So please, let's continue to join hands to help spread this good news. All right. So at this point, I would want us to move to the next problem of the day. So this is our next problem. How do we sort of determine all solutions of this particular PDE? And where are the solutions defined? When I also want to interpret our result in the light of the general local existence theorem. So if I were you, I'll just pause this video and try and solve it on my own. And afterwards, I'll compare my result to this. All right. So how do we, solve this particular PD? You want to determine all solutions of this particular PD with its associated initial conditions. Okay. So let's move on. So we want to write this. So we want to sort of say that X, let's consider this way. So we want to say that your X is equal to your X1 and X2. So let's do it that way. So we want to denote X to be your X1 and then your X2, okay? So let's consider that very, very important. Now, what to be the parametric equation to the given equation of a line. So this we're given this line, okay? So we have to parameterize that line, okay? So we parameterize this particular line. So the line x1 equal to x2 is parameterized, okay? So it's parameterized. So it's parameterized by g of z, which is going to be what? So if your x2 is z, then your x1 will be z. Is that okay? Good, good, good. If you understood the previous example, then it should be the same as that. Okay. So if your x2 is z, then your x1 will be z because of this line. Okay, because of this line. If your z2 is z, if your z2, sorry, if your x2 is z, then your x1 will be what? Z. Good. That's why we have that. Now we have to find the characteristic, we need to kind of determine the characteristic system of this particular PD. So the characteristic system then becomes what? Then the partial of xi1 with respect to t will be equal to what? Will be equal to your a1, and your a1 is your what? Is your a1 is what? 1 minus u. So your A1 is 1 minus U. But your U correspond to what? Your V, as we mentioned in the previous you know, example. And then the partial of xi2 with respect to T will be equal to what? We got your A2, and this your A2. Your A2 is what? 1 plus U. And what is your U? Your U, we said, is the same as what? Is the same as our V. Let's take note of that. And then what about what is our the partial of V with respect to T? And that we said it corresponds to the C. And the C in this question is what? Is 1. Okay. Our C is 1. And then we are given initial conditions as well. Okay. And let me what would be the so let me do the this is a partial of V with respect to T. We said it is 1. Now what would be the initial condition? The initial condition for Z of xi1, the initial condition for xi1 will be what corresponds to the first component of G, and that is Z, and that xi2 initial condition will correspond to the second component of G, and that is also Z. And what about the V? Will correspond to the initial condition here, which is what? 0. Okay, the V would always correspond to that. Okay, very important. Now, what we are left to do is to solve this particular problem. Now, when they look at how we can solve the system, the easiest way for us to do is to first solve, because there's the xi's or the partial of xi's are in V, in terms of V. So it's important that we solve this, we solve this particular, it's important that we will solve this particular system first. Okay. So on that note, we're going to have our V of Vt to be equal to what? The integral of the integral partial t. We want to solve this particular integral, and that gives us what? That should give us what? That should give us t plus the constant what? Z. But then remember, we need to employ the initial condition. Remember, we were given this initial condition. So when when t is 0, so when t is 0, when t was 0, when t is 0, we're going to equal that to 0, and that should give us z equal to what? 0. Okay, so on that note, we're going to have our v zt should be equal to what? Just t. Is that okay? Very important. So let's take note of that. Now, what do we need to do is we need to plug this. We need to plug V into we need to plug v into the other system so that it will be easy for us to solve. Is that okay? So on that note, we're going to have our partial of xi1 of respect to t to be equal to what? 1 minus v. And our v now, we have v to be t, right? So all that we need to do is to integrate it. So we're going to have our xi1 zt to be equal to the integral of, so we're going to have the integral of what? 1 minus t. And that gives us what? T minus what? T squared on 2 plus some constant what? Z, okay? And we need to we need to do what? We need to use the initial condition. And by using the initial condition already, we kind of know what we can get. We will eventually get the same thing because it's equal to just Z. Is that okay? When t is 0, we're going to have that to be equal to Z. Is that going to be itself? So we're going to have that. And then because we saw that, and we also saw that, let me use the other one. So the other one is what? The xi2, we saw that the xi2 was this, which is eventually the same thing. To be equal to the integral of what? 1 plus t and this. And that gives us what? Just t plus t squared when we integrate them. Then when we do it, when we kind of, find a particular solution, with a particular solution, we're going to rely on the initial conditions where t is 0. When t is 0, we're going to have this equal to be z, right? But which eventually means that the result should be the same. It just means that wherever you see z, you just replace by that, right? By z. So we are having what when the t is 0, when t is 0, we're going to have what? Z to be equal to z. Okay, so wherever you see z, we still have the same thing. Okay, good. Now we already know what we are having. So then now we have our let me use a different pencil rather. We have our xi1 zt to be equal to what? Our xi1, we are going to have t minus what? T squared on 2 plus z. But remember that your xi1 is the same as what? Is the same as your x1. That's what we said. Your xi1 is the same as your x1. So it is the same as what? And then your xi2 will be what? If your xi2 is what? Is your t plus t squared on 2 plus z, then your x2 will be what? Your x2 will be what? T plus t squared on 2 plus what? Plus z. Is that okay? Good. Now, we can kind of, use a technique. And what's the technique? We can try and eliminate z. We can do this by just subtracting, okay? We can eliminate t by subtracting x1 from your x2. So by eliminating, so the point here is that we want to eliminate t. So let's eliminate z, okay? So by eliminating z, then we are going to subtract your x1 from your x2. And that should give us what? That should give us t squared, okay? That should give us t squared. So this implies that, so it just means that my t will be equal to what? Plus or minus what? Root of what? x2 minus x1, right? But remember, so this yields, vt to be equal to what? T, which is equal to what? Plus or minus what? x2 minus x1. But remember, we said that UX is related to what? Is related to what? UX is related to what? V of what? ZT, right? We said it's related to that, right? This is T. So it just means that my U of X will be the same as what? Your X2 minus X1. So you're going to have two solutions. The positive sign and the right side will be the solution for the given U, okay? So we have two solutions, right? So these are very important areas that I believe we do not want to miss. And at this point, if you have not subscribed, please do so, and so that we're able to, tackle other interesting stuff as well. And at this point, remember the question was somehow a bit tricky. It says that we should, okay, the question was also, let's also take note of this, is where are the solutions defined? Okay, so when we look at this solution, at what point can this solution hold? Okay, we need to take note of this. This solution would only hold if and only if what? This solution, if and only if the expression under the square root is real. Okay, on the hot note, so this solution will hold. So the solution U will be defined. So the solution U will be defined on what? On x2 minus x1 greater or equal to 0. Okay, so this solution would hold on this. Okay, because if the term under the square root is negative, it means you're going to have some imaginary, of which we are not interested in that. We are looking at real solutions. Okay, so and this solution will hold if and only if x1 minus x2 minus x1 is greater or equal to 0. So let's take note of that. Very important, please. Let's take note of that. And the question went further to sort of interpret your result in the light of the general local existence theorem. So with that, we would use what we call the characteristic determinant. And what is the characteristic determinant? So let's look at something here, even though we did not talk about that, but I can use this to talk about the characteristic determinant. So with a characteristic determinant, what essentially we are going to do is that, so when you look at your G of T, so let's look at our G of T. Our G of Z was what? ZZ, right? So we need to differentiate that. Remember, the G is differentiable. When we differentiate it, we're going to get what? 1, 1, right? When we differentiate it, we're going to get 1, 1. Then we have to also, get, we have to also get the A component. All right. So our let me look at what we are trying to. So we have AX. You know, out of that, when we look at the A component in a given problem, we kind of um have this as your AJ's component, right? But we saw that your U was 0, right? So your U's was, so means that wherever you see U, just replaced by 0. So it means that we're going to have 1, 1 as our A's component, okay? So on that note, your A's will just be 1, 1. Then afterwards, we just have to find the determinant of G prime of Z and the A or A of X, U naught of X. So then we're going to have 1, 1, okay? Then we find the determinant of that. So we find the determinant, so we find the determinant of 1, 1. In our next example, we will solve more examples so that you will appreciate that. So our determinant will just going to be what? 1 minus 1, which is 0. So, this essentially means that we are not going to have we're not going to have like a unique solution. Okay, and that explains why. So this means that this implied there's no unique solution. This implied there's no unique solution. Okay. So this implies that there's no unique solution. So let me just use a different. So there's no unique solution. So anytime your determinant of your characteristic determinant is zero, it just implies that there's no unique solution to the given PDE. And that explains why we have two solutions over here. Okay, plus or minus root of x squared minus x1. And that explains why we have two solutions over here. So let's take note of that. Yeah. So in our subsequent problems, we would tackle one or two more examples, then we can before we jump into other stuff. So at this point, if you have not subscribed, please do so and um, um, turn on your notification button so anytime I release new content, you'll be the first to receive that. Please, thank you so much for your time. May the Lord bless you. All right. Bye.